Hey, welcome everybody, and here to show a little bit more about Rhino inside Revit and some ways you can use it. In this case, we're going to concentrate on an analytical model, structural engineering model, and how we can use the analytical information out of Revit to combine that information with other information. For instance, maybe could be Excel spreadsheet, could be in this case to get it off to an analytical analysis tools. And how we can do that all together, use Grasshopper to really bring all this information together in a dynamic situation. So we have a model here that we were sent, structural model, and I have a definition here that goes through, and as I've shown in other videos, we can go through and look at categories and grab all the objects off the categories. In this case, I'm looking at the analytical categories, in this case, the analytical beams. And I grab all the elements off those out of that category. In this case, I can convert them to lines, and then maybe we'll, in this case, I'll turn on here the endpoints of those analytical beams. You can see what Revit does here is that it has the beams, and then it has some intermediate points here, which I expect has something to do with if you want a special joint condition. In this case, that's not what we want, so we can use Grasshopper. I'll just turn these off. We can use Grasshopper to grab those lines and simplify them. And so what we'll get instead is more of the simplified kind of beams in this case. And so Grasshopper went through and cleaned up that definition, and so we have a much simpler model, and we have singular elements across here. One way we can use Grasshopper to clean up the analytical model a little bit on the fly. We can grab the walls, we can grab the columns, in this case, part of this model, the floors. Now, you'll also see that there's some lighter elements here, some lighter extrusions and some cross bracing here that don't show up in the analytical model. And the reason is that whoever modeled this in the first place did not turn on the analytical model for those objects. And it's nice. We can take Grasshopper here, grab those objects that do not have the analytical model set to them, and then we can actually, if I just turn on these components here, I can actually turn on using just setting the parameter enable analytical model on the objects, and I'll just recalculate here, and you'll see what Grasshopper does is it turns on the enable analytical model parameter on those objects. Revit will then calculate an analytical model object for those objects, and then Grasshopper can pick that information back up here, for instance, for the beams, and you could do the cross bracing or whatever it is and take it through and simplify it. So now you can see we have the cross bracing, we have the lighter joist framing here, and so we can use that now in our tool. Just to see kind of the information, because we actually have the Revit analytical objects and we can look back at the information on those analytical models. I'm just going to turn on layers here. What we can do is just to show, I have a bake component here. I'm going to press this button, and what it'll go through, and it'll go through all those analytical beams, and it will sort them by type. And so in this case, I know my circular section, what light joists we are, what kind of the round bar is. And then it creates a layer for each one of those, and then also puts those objects and bakes those into Rhino. And so just to kind of see the level of detail we have on all those objects in Grasshopper so that you can combine it and change that information as you need based on other information you have about the project. So that's one kind of level of detail that's interesting. Another idea is, instead of having to bake this information into Rhino and then send that off to another analysis tool, we can actually just grab the information and the geometry out of Revit and then turn right around in Grasshopper and push it right back out to analytics. So in this case, we're using Carumba, which is the built-in one of the plugins for Grasshopper. Allows us to do some structural calculations, but this could be any of the structural tools that you currently use, probably. So we simplify those curves again, and we grab, in this case, we're grabbing the columns, and so we push that column line into the ability to make column elements in Carumba. And then we'll grab the endpoint of those columns, and we'll create a end condition, a support at the base of each one of those columns. And then we can add something like, in this case, something simple like gravity. And then we have now a simple model that we can run our analysis on. What's interesting too is that because once I get this information back out, the actually results of the calculation, we could technically push the results back onto the Revit objects through parameters using Grasshopper, all within the same definition. And so there's a lot of, you can see how we can push and pull and grab information and really manipulate it in Grasshopper and then actually push it back to wherever we need to store that information. For instance, let's say back on the Revit model, if we're going to send that back out as the results of our analysis, or maybe in a report or Excel spreadsheet or something like that. So without actually having to bake it ever in Rhino. So I hope this shows some of the quick ways that we can use the information in an analytical model in Revit using Rhino.Inside and Grasshopper. And it'll lead to some ideas on some workflows that should be a little bit smoother, a little bit quicker than what you've been able to do before. The samples on this video, give it a try. We'd love to hear from you.